Asteroids are fascinating celestial objects that orbit the Sun, mostly found between Mars and Jupiter in a region called the asteroid belt. These rocky remnants from the early solar system hold clues about its formation and can vary greatly in size, shape, and composition. Some asteroids are just a few meters wide, while others can be hundreds of kilometers in diameter, posing different levels of risk to Earth. When asteroids venture close to Earth, they become known as near-Earth objects, or NEOs, and catch the attention of scientists and astronomers. Occasionally, asteroids can change their orbits due to gravitational influences, potentially making them a hazard for our planet. If a rogue asteroid were to collide with Earth, the consequences could be catastrophic, depending on its size and speed. An impact from a large asteroid could lead to massive destruction, triggering earthquakes, tsunamis, and even climate change due to debris in the atmosphere. Luckily, space agencies worldwide monitor and track these objects to predict their paths and assess any potential risks. Join us next as we explore how we can defend our planet from rogue asteroids and the exciting technologies being used. Asteroids are remnants from the early solar system, drifting through space. Some stay in their designated orbits, while others break free and become rogue. A rogue asteroid might be ejected from the asteroid belt or even originate from a comet nucleus, traveling alone across the vast cosmos. Once a rogue asteroid enters the solar system, it can be influenced by the gravity of planets and the Sun, altering its path dramatically. This gravitational tug-of-war can accelerate or redirect the asteroid, making its traveling speed unpredictable as it maneuvers through the solar system. As the asteroid approaches Earth, it enters the planet's gravitational pull, which can draw it into a potential collision course. Even small asteroids can become dangerous if they travel fast enough and collide with Earth, creating a significant impact. Asteroids are composed of rock, metal, and sometimes ice. When they collide with Earth, they release an immense amount of energy. The aftermath of such an impact could lead to wildfires, tsunamis, and drastic climate changes, significantly affecting life on Earth. So, how can we protect Earth from rogue asteroids? Stay tuned as we explore potential solutions in the next section. When an asteroid strikes Earth, the impact results in a massive explosion, releasing energy equivalent to nuclear bombs. This explosion vaporizes everything in the immediate vicinity and creates a large crater, altering the Earth's surface dramatically. Fireballs and hot debris shoot out in all directions, igniting fires across nearby landscapes and urban areas. The shockwave travels through the ground, resulting in devastating earthquakes that can topple buildings and cause landslides. Dust and debris are flung high into the atmosphere, blocking sunlight and causing a sudden drop in temperatures around the globe. These climate changes can lead to crop failures, creating food shortages and further strife for the human population. In the aftermath, people are faced with a disrupted society, struggling to adapt to the new harsh realities of life on Earth. Wildlife is also affected, with many species struggling to survive in the altered environments and harsh conditions. Despite the chaos, scientists rush to analyze the impact site, gathering data that may help us prevent future disasters. Imagine the sky turns dark as thick clouds of dust and debris obscure the sun after an asteroid impact. Light is dramatically reduced, altering ecosystems immediately. The temperature begins to drop worldwide due to the lack of sunlight. This cooling effect can create a new ice age, affecting all life forms and their habitats. In the aftermath, intense rainfall begins as the atmosphere shifts. The combination of dust and gas creates a heavy blanket, leading to violent storms worldwide. Wildfires could ignite in many areas due to the heat generated by the asteroid impact. The intense flames would devastate forests and habitats, leaving destruction behind. As ecosystems collapse, food sources dwindle. Starving species struggle to adapt, causing massive shifts in animal populations and threatening survival. Plant life suffers too, as vegetation takes years to recover from the lack of sunlight and extreme conditions. Without plants, the cycle of life is severely disrupted. Eventually, the dust settles and sunlight returns, but Earth remains transformed. The biome shifts can lead to a completely different array of species adapting to the new climate. As biodiversity shifts, new ecological interactions emerge. Predators may find new prey, and competition intensifies among species trying to survive. The long-term effects on climate and biodiversity underscore how interconnected life on Earth is. Each change ripples through the ecosystem, reshaping our planet. Imagine a world shocked by an asteroid impact, where communities unite to face an unprecedented disaster. How will humanity respond to this challenge? Countries would mobilize teams of scientists and engineers to assess the damage and strategize recovery plans in the aftermath of the impact. Governments would coordinate with international organizations to launch search and rescue missions in the hardest-hit regions. Hope and determination shine through. In the face of adversity, people would turn to each other for support, sharing resources, food, and hope in community solidarity. Scientists would focus on understanding the long-term impacts of the collision, studying environmental changes and their effects on wildlife and ecosystems. Public health officials would monitor the spread of diseases as communities recover, emphasizing the importance of sanitation and health education. As recovery ramps up, researchers would begin to develop new technologies and methods to prevent future asteroid impacts, signaling hope for the future. Communities would hold gatherings to remember those lost, fostering resilience and setting the stage for united recovery and rebuild. The journey of recovery after an asteroid impact would demonstrate humanity's incredible resilience, showcasing our ability to adapt and persevere against all odds. As we conclude our journey, let's reflect on the significance of preparedness in the face of cosmic threats like rogue asteroids. The impact of global collaboration is crucial. Nations must unite to share knowledge and resources to safeguard our planet. Building better monitoring systems to detect potential threats early can help us respond more effectively to rogue asteroids. Local communities play a vital role in preparedness. Educating people about what to do in the event of an asteroid impact can save lives. Innovative technologies like kinetic impactors and gravity tractors are being developed to alter an asteroid's course and protect Earth. Public awareness campaigns can empower everyone to understand the risks and the steps we can take to mitigate them. While we face cosmic threats, humanity's resilience and innovation will help us adapt and protect our world from potential disasters. Ultimately, the story of asteroids is a call to action for us all. Are we prepared for the challenges ahead?